Started on it. Okay, cool. Okay, I'll start the opening. Hello, good morning. My name is Chen, and today we are going to explore the two powerful creative thinking tool from a methodology called TREATS. Before anything else, can you hear me clearly? Is there any issues with? Can you see my slides?
I can't see your slides right now, but I can see you, and you're very clear.
Okay, so there's some issue. I'm just trying to resolve this one. How about now?
Yep, I can see your
Yes,
slides
sir.
now.
Awesome. Thank you for confirming. Okay, so let me jump to the today's running order. So it's gonna be a lot of small activities we're gonna do. Since it's just you and me, so probably we won't take all 80 minutes. So this one's built based on like having two audience to run the workshop within 80 minutes. But it's you and me, probably can keep this one short. And for the warm up, so we're probably gonna do the thing is I want to hear you like what's your background, Paul?
Yep, I'm a geotech engineer with about 25 years experience, and I generally understand what you've put up on the slides just to start with. The just various different trade-offs for one thing versus another. But yeah, I'm interested to hear about the rest of your seminar.
Yep.
Yeah.
Thank you so much, Paul. Thank you. So this is just like a basic warm up. Just expand the term of contradiction because this is the key term we need to apply today. So it's basically how things gonna have, for instance, like a high chance to workability, they are a contradiction, and speed of construction to quality, also the cost to durability. So that's quite simple, right? You get it? The contradiction part?
Yeah. There's a saying, I think you can have it. I think there's a matrix thing which has got 4 quarters, and you can have, I think it's fast, cheap, and
Yeah.
cost effective, but you can't have all of them. You can only have some of them.
Yeah, that's
There's
right.
always a
Yeah.
trade-off. Yeah.
Yeah. That's the term of contradiction. So let me just explain the original story of TRIZ. So TRIZ was developed by a Soviet engineer and who's also an inventor. Sorry, analyzed like over 500,000 patterns across industries. He discovered that only 40 inventive principles account for the vast majority of genius innovations, and contradictions are always at their core. The TRIZ term stands for the theory of resolution of invention-related tasks. That's the original story of TRIZ. So the first tool we're gonna apply today is the contradiction matrix. It has 3 steps. First, we need to identify the contradiction, and then we need to find the matching parameters from the contradiction. Finally, read the matrix table to identify the suggested inventive principles from the cells. So here's a short example we're gonna go through together, which is the coffee cup example. So for a coffee cup, we want the coffee cup to keep warm inside, but the outside where we are holding, we want to keep it cold. We don't want it to burn us. That's right? So that gives us the contradiction of having temperature to like harmful effects. So which gives us here from the 39 parameters of contradiction, that's 17, the temperature, and 31, the objective generated harmful factors. The thing about contradiction matrix, we need to also identify which one is the improving feature and which one is the worsening feature. So for this case, we want the temperature to be our improving feature and the harmful factors to be the worsening feature. So we want to keep it hot, but the outside don't want to burn us, right? Yep. And then from there, we can look to the matrix table. So we see the row stands for the improving feature and the column stands for the worsening features. In this case, we have 17 as our temperature, the improving feature, and 31 object generated harmful factors. From the matrix table, we can see this cell, which has 22, 35, 2, and 24 as our results turn out from the matrix table, which gives us the 4 traits principles we can apply to this question, which are taking out, blessing in disagreements, and in intermediary, also finally 35, the parameter change. So is there any question for now, Paul?
Not so far. I'd be interested to see how these principles apply from to solve your problem. So, yeah.
Yep. Let's just like develop from the coffee cup example. So taking out, we can think about having another objective. Let's say like 2 layer of the coffee cup. We have like air within between like 2 layers. That's all like a taking out because we're taking out the energy or the heat from the inside of the cup. So we're only holding the outside layer of the cup. That's all like a taking
Okay.
out.
Yeah.
Yeah, and so just one thing to know, not all like 4 principles we get from the matrix table are gonna help with our problem. So we still like need to identify which principle gonna be helpful, and then we can develop from there. It's not just like all 4 principles gonna be useful to our specific case or specific questions here. So since you're so like getting there, so probably we're gonna run through a short mini practice. So the problem is we want have high strength concrete, but increase the main content, reduce workability. So how can we use the trait matrix, the contradiction matrix method to solve this question? So similar things, 3 steps here. We need to identify the contradiction, find the parameter, and then look back the matrix cell. So I'll probably give you like 2 minutes to think about this one, or once you're done, just like give me a shot and we can discuss from there.
I know. I
I
understand.
will.
That's okay.
Yep.
We can move on. So I understand this. So the principles we're looking for are just the generic principles to solve the problem, or generic principles that we're trying to change. And in this case, strength is one of the problems that we don't want to decrease, and
Yep.
ease of manufacture is one of the things we want to improve the strength, but not reduce the ease of manufacturing. I think in this case,
That's right.
yeah. And then the matrix cells that it's going to present are going to be principles. Yeah. So those ones, convenience of
That's the
use.
stress and convenience of use, and
Yeah,
then
yeah,
look back to the matrix cell, right?
yeah. And so those
And
matrix cells, the principles that we're looking for that are going to be most effective in solving our or providing a solution are in that matrix.
let's see it
Yeah, yeah,
in red. Yep.
yeah. And those, uh, so, yeah, so taking out, what can you add? Separate workability function, color change. So these are basically giving you the core things that would be
Yep.
quickest to look at to get to your solution. So they're not
That's right.
providing a solution in themselves. They are providing you areas of thought in which to think about finding a solution. I believe that's the way this
That's
works,
right.
right?
Yes.
Yeah, yeah,
Yes.
yeah.
From each of the principle, we can sort of like a brainstorm from there and get multiple like ideas. It's not just like limit to one idea from each principles. We can have like a multiple one if we really good at bring like creative thinking.
Mm,
So
mm.
yep.
Yeah, so it's really
And
just the key. It's really just
yep.
the providing you a seed in which to do a brainstorming event to try and find a solution. So
That's
it's
right.
just a first pass. It's a first pass of a brainstorming event based on some methodology, really.
Yep.
Yeah.
Cool. So that sounds good. Let's go to the next tool. It's called the Smart Little People. So this one is quite interesting. So where did the Smart Little People tool come from? So it's the Ochler, I think I pronounced his name right. So Ochler noticed that miners in a dusty mine could not see a solution, but imagine tiny little particles choosing where to go unlock new thinking. So by replacing the material with a crowd of tiny smart people who can think, feel, and rearrange themselves, we bypass fixation and on existing form. So like let's see like how we can use it. So it has like 4 steps we can follow. The first one is replace any material or substance with tiny intelligent people. And then we can ask, what are they doing right now? What's going wrong? And then we design, how could they rearrange to fix the problem? Finally, we translate back to what engineer solution does this suggest. It's quite tricky and hard to understand, but with the example we can really get there. So here is the short mini example here. So the question is, why does water pool on a flat roof? Describe the problem using little people, and then we can redesign it. So 4 steps apply here. First, what are water people doing when the roof is flat? So imagine water particles be some like smart little people. So we also have gravity, and also we have the flat roof. So there are 3 group of people there, smart people. So the water people, they drop from the sky all the way down to the roof. Since the roof is flat, the roof people does not provide any extra force or extra energy to help the water people move. Say similar applies to the gravity. Since it's flat, there's no way they can help the water people to move. So the water people just stay there because there's no external force to help them or to push them. Just like you and me as human being. If there's no need to move, why would we move? We just stay on our bed, right? Just take a rest, have a chill. And why do they stay in one place? What stops them moving? So there's no external force to push them or to force them move. So that's why they're just like stopping there. So what if they could decide where to go? How would they escape? So if there's some external force to help them to move, they would definitely to go to somewhere lower, let's say the ground or something just lower than the flat roof. So from that case, we can see what does this suggest about the roof design. We want to have the roof design to be so like a slope, having some slope instead of a flat roof, so the water can move freely to the ground. So we don't have like a water pool on our roof. That's basically all kinds of roof design we see here around Auckland. The roof are not flat; they're just having some angles there, slopes there. You getting there, Paul? Or
Oh
is there
yeah,
any
no, I
question?
understand. I understand the concept.
Yeah,
So
that's
I've got
cool.
an
That's
image in
cool.
my mind of like the various different groups of people and
Yeah,
what they would need to do to escape. So um, yeah, in this case, the it's an interesting exercise.
yeah,
Yeah, just as an aside, when I was at school, our physics
uh-huh,
teacher used to describe things along the same sort of format, little
uh-huh,
people doing things.
uh-huh.
So
Yep,
it's not an alien concept to me. So yeah,
yep,
just in terms of what that's going to do. So I think this could be like a long stretch for some people, but I've got it in my mind about the various little groups of people trying to do their own little things
yep,
with the constraints that apply to them.
yep,
So yeah, in this case here, the gravity people aren't really doing anything because there's no
yep,
gravity pulling down. So
yep.
you know they can probably provide the most use to help the other water people, but yeah, in this case they're sitting there doing nothing.
Yeah, cool. Awesome. Thank you.
Yeah.
And so we jump to our main work example. This is the so like a key task we're gonna go through together today for a realistic problem. So we all gonna see in a construction site. So it's the speed versus quality issue. So a road contractor needs to compact subgrade soil quickly to meet program, but fast roller bypasses reduce compaction quality, leaving weaker, less dense soil that cause pavement failure. How do we compact fast and to high quality? So since we're both in like the construction industry, so we understand like this concept here. So this is sort of like a question we need to kind of like face a lot during construction, right? So the speed versus quality issue. So let's see how the trees method can help us to solve this question. Since we've just talked about the smart little people principles, we're gonna apply this tool here. So start with, we can imagine soil particles as little people. When the roller moves fast, they don't have time to arrange them. So we sort of like a need to redesign these little people or their interactions with the roller so they can quickly apply at high speed. So probably I'll give you a couple of minutes to think about this one. And so what I want to hear from you is the idea and how you apply the terminology of smart little people.
So, like, I can think about this because this is a common problem.
Uh-huh,
So,
uh-huh. Yep.
so in this case here, you've got smart little people, which are the soil particles, but you also have
Uh-huh.
smart little people, which are the moisture between the soil particles. So you've got
Yep.
two groups of smart little people here.
Yep.
You've got the soil particles and you've got the um, water particles. And I
Yep.
guess in this case here, you also have a group of smart little people, which are groups of people. So,
Sorry, Paul, I just
you know,
lost you
you've
there.
probably got
So
three.
after the moisture people,
So you've probably got also the force people pushing down, which is the
false
roller,
people,
the group.
Dora.
Yeah,
Yep.
people. Yeah, to represent the roller people.
Yep.
And then, yeah, so those would be the main three groups of people
Three
that you've
people.
got in this.
How
Yeah.
about the air people within between like the soil particles, soil people, the air?
It's less important. The air people can escape quite quickly. So I think
Mm-hmm.
it's probably they're not as important. It is important to
Okay.
get them out, but
Mm-hmm.
it's the water people and the soil people that are the most
Soil
important.
people. True.
Yeah,
Yep. Okay.
yeah, yeah.
And any ideas you can develop from those three groups of people?
Most of the time when it's the water people can't escape quick enough is the
Mm-hmm.
problem. So when you're doing
Water
a
people.
fast pass,
Mm-hmm.
you can't get the water out fast enough, which is causing the problem, right? So that's generally um, the biggest issue with roller subgrade. So
Mm-hmm.
um, the most ideas are how do we get the water people to escape faster, and
Mm-hmm.
then often we have another group of people which is turning everything over and mixing everything up to allow the water people to escape more freely,
Mm-hmm.
so they can jump
Mm-hmm.
out of the surface and run away effectively in this case. So
Mm-hmm.
a lot of the cases drying is required, which means your water people have got to escape more quickly.
Yep.
Which is one way for a cohesive soil. Yeah, for something that's fine grained, that's tightly packed together. Yeah, that'd be the
Mm-hmm.
way.
Mm-hmm.
Yeah, so that's kind of what I'd be looking for. Yeah, so the roller packing down quickly, the force guys, they can't really change what's happening under them so much. All they can
Mm-hmm.
really do is push down, but it's the water guys and the soil guys that have got the most impact. So
Mm-hmm.
well, one of the things we could do is make the soil guys bigger because that will help compacting at high speed. So if you can control the size of them and
Yep.
make them larger, that would help.
Mm-hmm.
Um,
That's another
and
idea.
yeah, or if you can find other ways to tie the water people up so that they can't. When the roller people are pressing down on them, they're pressing back effectively.
Mm-hmm.
So you've
Mm-hmm.
got two forces: water people at the bottom and the roller people pushing back. But if
Yep.
you can find a way to tie up the water people so they're not pushing back, that's a good way to speed up
Yep.
compaction as well. So
Yep.
yeah, um, yeah. Um,
That's three ideas you've got here. So probably I will share my thinking here.
yep.
So I'm thinking about like having the like a soil people to jiggling like vibration of the soil people. So imagine since they're smart little people, right? So imagine like just some people there in a really huge city of having a metro or subway. The cabin is full of people, but there are some more people wants to go in. What they do, they just squeeze each other, right, to create
Mm,
extra space. So in that case, so if we're thinking the soil as some smart people, if they saw like a vibration or jiggling, so they can like compact faster, right?
mm,
So
yep.
for that case, we can have the roller to roll over them, and meanwhile just do some vibration if that's possible, right?
Mm,
That's another idea here,
yep.
and probably some more ideas, so like let's say add some extra chemical to them. So add another group of smart little people, some chemical things that help them to so like just compact more easily. But it's something we need to develop further. But this is all like an idea we are looking for here.
That kind of tees in with what I was saying is you need something else to tie the little people up. If you add another group of little people to tie up the water
Yep.
people so they can't act, that's acting, those other group of people are your chemical in this
Yep.
case.
Yep.
So, yeah.
Cool. And also, we're probably kind of thinking to reduce the thickness of the soil layer. So probably just having extra layer of concrete or whatsoever. So there's less people. We need to get them rearranged, right?
Mm.
There's probably another idea here.
Yeah, or you could add another group of people that hold hands effectively and increase the strength so that when you're compacting, you're getting a strength increase. Um, and such as a geogrid or something, effectively another
Yep.
group of people that are all locking it all together.
Yep.
Yeah.
Cool. Awesome. That's pretty good. That's the first tool we applied to this question. So here we need to use the contradiction matrix tool. Do you still remember the 3 steps for this tool?
Yep. So you've got to select the three things that we're trying to do, right? Or
Yep.
two things that we're trying to do. So let's read through them.
Yep. So it's a pair of
We,
contradiction.
yeah. So it's either the 14 strength or and
So you reckon it's
yeah,
14. Yep.
yeah, and then maybe 15 duration of action by moving object. You want to
15.
reduce, yeah, or yeah, yeah, those two would fit, 14 and 15.
Okay. Yep. And and okay, so that's 14 and 15. So let's see how 14 and 15 can go. So I've sent you the Excel sheet of the matrix table, right?
Yeah, just let me look at that. Give me a
Yep.
sec.
So can you tell me what are the matrix cell you're looking for to get the principles?
Just a sec. Let's read it. Oh, just
Yep.
looking at another.
Yep. That's cool.
Look at 14 at 15. So we want to increase strength. So we want to improve that. So if we use 14, let's select and highlight that row, and then 15 must be the action. So in this case here, it would be 27, 3, and 26.
So let me go back to this one. So 14 to 15, that gives us 14 to 15. So 27, 3, and 26, right?
Yeah, yeah.
27, 3, and 26. Okay. So we go back to the principal table here. So 20, 22, that's blessing in disagrees, and 3 is local quality, 26 is copying. Do you see any ideas from those principles? Or they're just like irrelevant here?
Um, let's go. So what was it? Local quality was 3, right? And
Yeah, that's
then
right. 3
we had
and 22,
27.
20, it's
No, was
27.
it
Oh,
20?
27, sorry.
Yeah, 27 and
Chip
26,
shot the
right?
object and 26 copy.
Mm. Yeah, I think to extrapolate them, it does require a bit of thinking, right? So
Yep.
in maybe I haven't selected quite the right versions. What did you use in terms of this example? In terms of like, just because I'm trying to get familiar with
Yep.
that screen in terms of the. So we'll just have another look. So strength is what we're trying to increase, right? Or stability of an object's composition might be, but probably strength I would have thought.
So I'll go back to
Worsening
this question
features.
here.
Yep.
So the key things we're looking at is how do we compact fast and to high quality. So those are the 2 things we're looking at.
Mm.
So probably divide from that sentence here. So we want to compact fast and keep high quality.
So we're going to compact fast, right?
Yep.
So is it the length of a moving object? And what is there a quality one in here? Extended automation to put detecting device adaptability. Um, quality or quantity? No, it's quantity of substance.
It's quantity. Yeah.
Yeah.
So probably I will give you a heads up. So the one I'm thinking about this question is number 9, the speed, which means like fast,
Oh,
and
okay. Yeah, yeah.
also the reliability means the quality, right?
Yeah, yeah, that's probably a better fit.
So
Yeah,
it's
yeah,
the speed and to reliability. So we
yeah.
want fast roller process, but we want to compaction quality. We won't have the compaction quality drop. So that's the speed to reliability.
Yeah, yeah, yeah. Okay,
Yep.
now I get that. Yep.
So I will just go back to this page, and you can use the matrix table to tell me what are the results you get from the matrix cell regarding the
Okay,
speed to
so
reliability.
look at speed and what was reliability? What number was
27.
27? So 11,
Yep.
35, 27, and 28. 11,
11,
35.
35, 27, 28. That's awesome. So those are the 4 principles we are looking at for this question. So we can have the 11, the beforehand cushioning, and 28, mechanic substitution,
Yep.
35, parameter change, 27, cheap short-living objects.
Okay.
So like a pre-wet the soil before rolling begins, or like taking the try to get the water out. So it depends the circumstances.
Yep.
And then we can have the vibration jump, which is also the jiggling thing. And parameter change is the change layer thickness of roller, or like roller frequency. So that's the parameter change. And cheap short living objects, so we can replace the current expensive objects with so like a multiple inexpensive ones, as long as they fits the standard, so we can have them to
Mm.
change. But there's some more ideas if we can see from the 40 principles. There's only, we can't just limit to those 4 principles. Those are the 4 most likely principles to help us to get the possible solutions to the question, right? So
Yep.
there's still some more we can look up, but these are just some like most likely
Yeah, I
solutions
think.
here.
Yeah, I think you could probably interpret them slightly different as well. So sort of like if you just go back that one screen. So
That's
your
all.
parameter change, yeah. So adding a chemical as well is a good parameter change. So
Yep,
adding, yeah.
that's right. So yeah, also if we just see this one and refer this one back to the smart little people, we can see there's some similarity, right? So
Mm. Yeah, yeah.
the the jiggling part, the parameter change part, they're just like really sort of like giving you sort of like ideas by using different tools. So we're getting there.
Yeah.
So that gives us to sort of like the idea selection. So these are the 6 ideas I think before.
Yep.
So like pre-wet, so like a pre-cheat. So it's not only like pre-wet, we can also like try to take the water out. So it's not
Mm.
treatment to the soil, vibration roller, and thinner compaction layers. Probably like intelligent roller with density sensors. That's like a, if we can't have like all the soil layers to be same. So like um what's the term of like compaction, the level of compaction.
Intensity. So,
Yeah, that's right. Yeah, so
yeah.
because some areas they probably require more compaction, some area they're just like okay with that. So we
Mm.
can have like a intelligent roller to identify which part that requires more compaction. So they can move fast on areas that doesn't require much compaction, and don't go slower on the areas that require more compaction.
Yep.
That's another idea here. So, and also number 5 is like cement soils, spillage,
Stabilization.
stabilization. That's the one. Yes. Um. So replace the multiple chip layers, chip rollers. That's another idea here. So sorry. So maybe I will just like give you some like 3 votes here to choose about the best idea here. You can just go for vote like one idea twice, or just like go for one for each.
Mm. Okay. Uh, on these ones?
Yeah, and also the one you think of. So we've got your one like the having like larger soil guys, right?
Well, it's
So
going to add
so
other stuff. So this one here with the one that's probably going to be most effective is probably 5 lime cement soil stabilization. It depends on the soils, right? So
yeah, so probably large soil,
soil like adding
just like this.
larger particles or changing the composition. But
Uh-huh.
yeah, yeah. But I think soil cement stabilization is probably going to be and if it was a sandy granular material, then number one as
Uh-huh.
well would be the best 2 options. And then if it
Uh-huh.
is this, it just depends on the composition. If it is a sandy material, then item 2 would work as
Yep.
well.
Yep. Yep.
So
So it really depends on the circumstances of the question, right? But so
yeah,
like this gives ideas to how to select the ideas we get for to solve the question. So not only we can just like vote them, we can sort of like create
mm,
them like a vector matrix to give them different rankings to so like a number them
yeah,
up to see how from the like a cost perspective
mm,
to easy to use perspective and
mm.
all kinds of that and just like give them rankings on that.
Well, so what I can see
That's
from this, what I can see from
yep,
this is that even if it's not super specific about finding the solution, it actually is prompting you to ask the question of what's causing the problem as well. And so this is
yep,
giving you a good idea of what's causing the problem because
hmm
it might not be specifically exactly related to one of these things, but it gives you an idea of what questions to ask about
yep,
what was causing the problem, which is quite useful as well. So not only solving the problem, but better questions to ask to solve the problem. So
yeah.
it could be
Thinking back of the question.
yeah, could be
Yeah,
iterative.
cool, awesome, cool. So probably for this one, it's really for the voting. It really depends on the question itself. So that's okay.
Yeah,
We
yeah,
can leave this part. Yep.
yeah,
Finally is the feedback and the code section. I will share this link to you
yeah.
just in a minute. Link. Okay. Send it. Okay. So the link is in the chat to the Google Form.
Yep, cool. I'll do that
Uh,
shortly. Yeah,
Thank you. Yep. Is that
yep.
possible? We can do it now. So I'll give you like let's say like 3 minutes, so we can go just review
Okay,
the outcome of the Google Form. Yep.
okay. Just one moment. Just give me a sec.
Yep.
Just open up
That's
the
okay.
chat. Let's see. My computer's not very fast. Just give me a minute.
Yeah, that's okay. That's okay. Take your time.
It's going to load eventually. Oh, it's not loading quickly. Let's close most useful. Oh, yeah, I can. Okay, it's got a few questions.
Yep. Yep. Just take your time.
Right, submitted.
Cool. Okay. I
So
will
I'm
just stop sharing
happy
this
to
one.
talk you through it as
Yeah,
well.
yeah, I will just open that page and share that. So just a minute. Let me share this page here. Yep.
I see you had a few people.
Yeah, they're from like yesterday's workshop. So
Okay, cool.
yeah. So if you've got so for this first one, so probably you can go through this one. So you know
Yep.
what you just wrote, right?
I know I feel reasonably confident in working both with the contradiction matrix. You can just scroll
Uh-huh.
through this quickly, and then the smart little people, I understand that
Yep.
conceptually quite well.
Uh-huh.
Um, the workshop was good. What I would do if you just scroll down to the end, what you
Yep.
could do better is maybe provide in the small little people
Mm-hmm.
example as an actual diagram of how this relates to your roof example.
Yep.
Draw the little people up. Um,
Mm-hmm.
uh, yeah, so I think that would have been really useful. The worked examples are really, really good. So I'd concentrate on doing those worked examples, I think, and take a bit slower to do those. I think that would be good. And I think
Mm-hmm.
for the Russian matrix, the what I would end up doing, what would be quite useful is if you kind of discussed in a project and then asked your audience what aspects of a project could have an influence on the project directory, like speed or you need to find some way to prompt people to get to the same sort of answers that is in that matrix, and then introduce the matrix after that. So say, okay, what are the factors in your project that you might think about that we need to fix? Is it, in the coffee cup example you gave, it's like, well, the temperature, or you could talk more generally around that example and then ask people about what you're trying to achieve and then jump into the matrix. So
Mm-hmm.
try and get people, because what you're trying to do conceptually is get people to go from their specific problem to how it fits in with that matrix. And that's the bit of I struggled with, is going in the short time we had, is going, okay, well, how do I bring in my issue and fit it within that matrix example? So there's a little bit of a conceptual jump between a specific problem and that matrix thinking and then bringing it back. So,
Yep.
yeah, worked examples around that and maybe just more effort to try and bring people to so they understand the conceptualization of how to put their problem into their matrix and then how to
Mm-hmm.
bring it back out. And part of that is the example saying, okay, well, look, in your coffee cup example, what are the things that are happening in reality that we're trying to fix? What are we trying to control? What things control that temperature? Is it quality control? Is it composition? Is it, because these are all things that are in the matrix,
Yep. Yep.
prompt them. So then when you bring in the matrix, they can go, okay, well, look, here we've discussed those. Yeah, I can actually see those. It's not strength, and then just
Mm-hmm.
maybe have a discussion around generic properties that you're looking for them to extract so that when they chuck them in the matrix and they go, okay, yeah, I can see those connections,
Yep.
Yeah.
Got it. Got it.
Yeah.
That's really helpful. Thank you so much, Paul.
Yep.
And one last thing I'd like to do with you is let me just share this screen. So it's here. So like we need to develop a smart plan to think how can the teaching could be improved and roll out more widely. So this is
Mm.
the thing probably we can discuss together.
So I think, in my opinion, um, like it's a lot of content in a short space of time. I think one of the things you could look at is breaking it into maybe two seminars, or break the seminar
So
into
like
two
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 parts.
single tool workshop instead of like just bringing two different tools at once, right?
Yeah, you could do that. Yeah, break out the tools into two different workshops, and then
Mm.
think. But in terms of a smart, specific, measurable plan, what would you do? You would say, okay, well, look, it's more about the teaching methodology and how to change your teaching to get that. And you're already doing a lot of the stuff, which is all surveying, which is a lot of how these goals are reached by surveying and then
Yep.
getting satisfaction metrics from your people that you're teaching. So I think you're already doing to me, like, you're already doing what you're doing because you're already surveying at the end of the course, and that is basically the most important aspect. You might want to consider, is there anything else that you could survey that could help you make this more specific? But
Mm-hmm.
yeah, you're already doing the biggest component, which is making sure that you're surveying people who take the course, right? That's the same with every
Yep.
university course. People to survey it. There's a survey at the end of the course, and they use those survey results to change how they run the course potentially. And then the specific and measurable goals are a greater level of satisfaction each time they run the course from the changes that they've made to it, right?
Yep. Yep.
Yeah.
And that's how the teaching could be improved. So thinking about like how we can roll out this more widely.
Mm.
Is there any thoughts on that?
So if you want to run this out more widely, you've got to think about who your audience would be. Do you want to have people who you want to train to roll this out as a method of thinking? And if that's the case, then you need to probably introduce a second course on how to train the trainers, right? So,
Yep.
you run a first group of people as students, and then you run them as the same thing through as trainers. And that would be the thing, saying get their feedback from both being a student and being a potential teacher of this, because they'll have different insights for the different, as their roles different. Like as a student, I'm just going absorbing this, and there's some good things, and I haven't really had to think about how to train other people. So if you want to roll it out, you've really got to make another, and you want to roll it out so that other people are training the course, or that who will be teaching it potentially.
Yep.
You need to roll it out to them more specifically and saying, what can we do to make this more improved as well? And then it'll have good iterative feedback and in fact, it'll have a lot faster because you'll be getting a much bigger pool of people with different perspectives. So I think that's a good idea as well. If you came back to all the same people and said, oh, so how do we teach this? What do we need to do to change it? You're going to get a different perspective from a student who says, well, I'm being taught and this is what I want to see changed, right? So maybe that's one of your specific goals is get the students that you've taught and say, okay, well, look, now we want to teach this. How would we do it? What changes could we make to make this? Because I think you'll get different feedback, to be honest.
Yep. That's interesting. Thank you.
Yeah.
I could share you with another like idea I've discussed with another group of audience from yesterday. So we think about probably having myself to create a short clip or regarding the trades principles, and then so like we can upload this to our social media, and for some audience who are interested in, like, we can share the link to them, and for let's say weekly I can host a QA session for them to ask me any specific questions if they have any. So that's probably gonna save us a lot of time, because not every people gonna like ask me questions if they do understand the content within the video, right? And also another thing we could have is to build a discussion board. So let's say, so we have like a group of audience. The audience A, they gonna ask me some questions regarding the terminology or whatsoever. But audience B or C might have the same like questions they want to ask me. But if they see audience A already posed this question and I have replied to him, so the B and C could just like read my reply, and then so they don't need to ask me again. So that's both save me and the audience time, right?
I think it's good. And in fact, your social media idea, I think, is really useful. I think if you were to relate what would be really, really valuable is seeing worked examples and different work examples. So if you had a social media and you're giving a weekly worked example and then taking questions from your own worked example, this is how I use it in my work today. And I did this, and this is the critical thinking that allowed me to, and just show where it has its value, right? So, you're trying to demonstrate a value proposition ultimately and using this methodology. And so, okay, well, look, what value did it allow you to think? What critical things that allow you to think of in your work particularly, right? So I have a problem, and then I
Yep.
use this methodology to solve my problem or to solve me and allow me thinking around it, and then that's your social media presentation for the week, and then you can do Q&A on that, right?
Yep.
And
Yep.
people can see how it's being used in practice.
Hmm.
Yeah,
Yeah, that's pretty good.
yeah.
All right, I think that's the end of this workshop. Thanks so much for attending, Paul. That's
Yep.
really helpful. Thanks a
No,
lot.
no problem. Happy to help
Yep.
out.
Okay, cool. I will stop recording now.
Yep.
Uh, stop sharing and stop recording. Okay, cool.